This lesson will teach me to identify perfect square trinomials and perfect square binomials, and this lesson will teach me to multiply special binomials using a pattern. There are two special cases, one of which is a perfect square trinomial. In a perfect square trinomial, please notice that the answer is a trinomial. It has three pieces. It's referred to as a perfect square trinomial because the first value and the second value are perfect squares. By perfect square, we mean numbers like 4, 9, 16, numbers that are created by multiplying a number by itself. The other thing to notice about a perfect square trinomial is that when you start, you get, for instance, you'll have the same binomial squared. Let me show you how this works. X plus 3 squared, I'm going to use that as my example, means that I have x plus 3 times x plus 3. When I go through and distribute, the first term and the last term are perfect squares. X squared was created by multiplying x times x. 9 was created by multiplying 3 times 3. The two center terms are identical, and what happens is that they combine. So the pattern is that the first term is squared, the last term is squared, and the center term is combined from those two like terms that are created when you multiply. Let's look at it with another example where there's a minus. I don't want to. Let's try 4. So x minus 4 times x minus 4. There's the first part. That minus 4 is going to appear twice, and a negative 4 times a negative 4 is a positive 16. So following this example, I have my x squared. Notice the difference? Something to notice. The signs, because I'm taking a negative and I'm subtracting from it, it's a minus 8, and I have a positive 16. So again, something to notice. Those signs are the same because a positive squared and a negative squared are both a positive. All right, so let's look at this as if we were using a shortcut. Think about the first value, this a value being squared, x squared. For the last term, it's going to be b squared. So this b value, 4 squared, 16. This number in the center is 2 times a times b. 2 times the a value times the b value is what gave me my 8x. Let's look at it with this example that I created just up here above as well. If I were to take the a value and square it, well, there's your a value. If I were to take the b value and square it, there's your b value. 2 times the a value times the b value is that 6x. Now the nice thing about this is it is more of a shortcut than anything, but if you get good at the pattern, it can save you from having to write the problem out twice just to end up with the same kind of answer each time. All right, our next shortcut, or our next special case, is a difference of two perfect squares. Please notice here that the answer has a minus in it, and the idea that it's of two perfect squares. Here's a perfect square, here's a perfect square. What happens in these cases is that when you go through and you distribute, let me give you an example. Oops. When you go through and distribute, there's your x squared, but in these problems, notice that the signs of the 3 are opposite. So instead of combining like they did in the previous example, here they're actually going to cancel. X squared, that's going to give you no x's, so I'm not even going to bother writing it, minus 9. So it's going to give you a difference, meaning a negative, of 2 perfect squares. Whether the plus comes first and then the minus, or whether the minus comes first and then the plus, those two center terms are going to cancel every single time, leaving you with only those 2 perfect squares at the end. All right, multiply using the pattern. If you don't like the pattern, you won't be forced to use it. The pattern's going to save you time as the problems get longer, and the problem's going to save you as you get to the end of the unit. But it is perfectly okay to stop for a second and just multiply, as a lot of you know how to do. Feel free to do that. I'm going to go ahead with the pattern. The pattern says that when this is a perfect square trinomial, and I know that from matching it to my notes up above, I'm going to square the first number, I'm going to square the last number, and these two numbers multiplied together are going to be doubled. So that's 7 times x, but times 2 is a 14. Again, here's another perfect square trinomial. I square the first number, I square the last number, these two get multiplied together, which is going to be a -2, and double it is a -4. If you don't like my shortcut, don't use it, but you need to be multiplying. All right, C and D. Make sure that those make sense. Letter E. Letter E I would classify as that difference of squares. I can tell because those signs are opposite that when I go through and multiply this, they're going to cancel each and every time. If you want to go through, go ahead and start double distributing. Recognizing that it's a difference of squares lets me know that my first term will get squared, my last term will get squared, and those terms in the middle won't be there, leaving me with x squared minus 21. Again, letter F is a difference of squares. I know my answer is going to have two perfect squares with a minus in the between because the plus and the minus are going to end up canceling. I'm going to have a c squared, my center terms are going to cancel, and I'm going to have minus 64 because 8 squared is 64. Looking at G and H, let's see, my first term is going to get squared, and my last term is going to get squared. If you don't like my shortcut, then you're multiplying each and every piece. One problem left. Find the expression for the shaded region. We did a problem like this in the previous lesson. When we find the area of the shaded region, we're taking the area of that large rectangle and we're going to subtract away from it the area of the small rectangle. Make sure that you keep that grouped and this grouped as well. The big rectangle is x plus 4 times x plus 4. You're more than welcome to multiply that there, but I recognize that when the same number is written twice, it's like squaring it. Essentially, this is a perfect square trinomial. So the area of the big is x plus 4 squared. The area of my small in here is going to be x plus 1 times x minus 1. I recognize that as being a difference of squares. So my perfect square trinomial is going to give me, and my difference of squares is going to give me, so now when I go to subtract, x squared minus x squared is 0. 8x minus no x's over here. 16 minus a -1. 16 minus a -1, those turn to a plus, is 17. Thank you very much. Please let me know if you have any questions.